NxtQuad. We have built an NxtQuad system to control a quadcopter over internet. Our control interface is Android phone, and our communication interface is ESP8266 module, which is a Wi-Fi module. And we have implemented a mix-based Arduino code onto the NxtQuad system to make interfacing more easier and debugging really quickly. Let's see how it works. So we have built a Android phone application which is connected to the Blink API server, and our ESP8266 module, which is mounted on the NxtQuad FPGA, is also connected to a Blink API server. So when we send a command over the phone, ESP8266 module will give it to the NxtQuad, which then processes it and transfers it via RF transmitter to the quadcopter. So this is our tiny list. Let's see.
So the first thing was in our early proposal we wanted to do it using PicoPlace, but since all of you guys know how painful it is to do stuff in PicoPlace and writing, and instead of that we were using two different protocols. One was SPI, another was UI. So you can understand the pain of doing that in using a PicoPlace. So initially we were trying that on Arduino by figuring out how the ESP module works and how to interface that, since it uses multiple baud rates, and synthesizing each time the PicoPlace stuff was getting painful. So we were doing it on Arduino, and we were just googling about any other solution. So fortunately we found one Arduino Power Online, and it is a mixed processor. It's a 5-stage pipeline processor, which like most of us have studied in the MSD and Compart classes, and it was implemented earlier on Ultra board, and it was working, and the next port was on basis. So that gave us opportunity for the Nexus 4 thing, and we actually implemented three things on our Nexus 4 DDR. First one is the mixed core. It was a base core, and we made it run at 100 megahertz. The next thing was UI. So in UI, the best thing we have is we are using only single port to program three different devices. It can program the NxtQuad FPGA, it can program the UI, and it can help communicate the UI, that is the ESP8266, with the Nexus 4 itself. So there are three different internal ports which we have configured, and they are configured at different baud rates, and they can run successfully on three different baud rates. So that was all about the Arduino part. Now the programming IDE. In the programming IDE, we had the base IDE and the base libraries, which are based on the Digilent Basis 3 board. So we needed to dig in a lot of different stuff and make some changes to make it work on Nexus 4 DDR. And we got it working on Nexus 4 DDR, and we were able to make it support the UI very nicely. Like we were even able to program it at 3 megabits per second, which is quite a high baud rate, so that we can keep the low latency with our ESP. The next was SPI. We tried to configure the SPI, but since the internal library was broken, so we planned to do the bit banging thing using Arduino itself. So we have written a small part of code which does nothing but a bit banging using the shift algorithm, which generates clock and other stuff, and we were able to get quite really good response on the oscilloscope when we were checking for the MISO using bit banging, since the processor itself is running at 100 megahertz. So that helped us get a very high and really good response with the different modes, which is supported by SPI. So yeah, this is our ESP8266P mod. So we have configured it at one port, and it can be used with any PMOD interface, since it uses standard pin interface, and it has two different buttons. One is for flashing and one is for reset. So the ESP8266 is quite one of the most difficult model to program. So like a lot of guys knows from 540 projects that it is really difficult. So it was really good to work with that one and figure out that it really works well. So we would like to show a bit about the Arduino IDE and how it actually runs a simple blinking program. by just programming an FPGA. Means you don't need to actually put clock divider, you don't need to create any counter stuff. You can just write an Arduino program, it makes the LED blink on the Arduino.
So this is actually the Arduino laptop.
Yeah. You just change the pin number and it makes the LED blink.
You need to put a laptop, not an HDMI.
Yeah. So I just want to show you something. This example might be easier.
Okay,
Not blocking it. So
that's through SPI, right?
Yeah.
yes, this is our soft SPI.
So we tried to use the SPI library, but since the internal SPI was not working well, it is a bit broken. The address was not accessible because of the VRAM. We don't have too much visibility inside. So what we did is we written a small routine. Just pull up. So that's it. That's the SPI transfer routine. It just takes the data. It just takes the 8-bit data and it just writes the serial clock low. It drives the serial clock low. That is the basic SPI protocol. That clock should be low at start. And we are implementing the mode 0, the SPI mode 0 here in this one. And it just do the shift and right kind of algorithm. That's how it is.
Set it to mode 0.
So we are using just to push not push button, just two switches to change the different modes for the UARTs internally. So like you can see here, we put a new mode into the library, that is DDR, Digital NxtQuad DDR mode. Oh, which program are you? Just put it here. We need to program the ESP.
So I've just set the program to, I've set my throttle up and down on my ESP8266. So if I click up, it should, the LED should blink based on how I'm. So right now it's just going through the cloud, connected to ESP8266.
So though it looks like it is just connected here, the real thing is it uses the Blink API, which we told as in our project report that it is a Kickstarter project. And they actually open source their APIs and servers. So it was just a free app on Android. You can connect to internet, and the ESP is connected to internet via Wi-Fi, and all the data is transferred online via Wi-Fi itself through internet. And the most amazing thing is it has nearly zero latency, because you can see the real-time response.
Yeah. And
which one is the router? Is the phone?
This is
Oh, that's a router.
yeah, that's just a Wi-Fi module.
No, that's
so this is connected to the internet, as well as the phone is connected to the internet. So any signal.
Yeah, what is the
Right, but what's the access point?
Oh, it's just the cloud server they have. It's a Blink.
Right.
The API has a server, and we just connect the server connects to the module directly.
So you've got like a hardwired IP address? And
No.
No.
Yeah, it just uses the port number.
Their API. Their API port address, and it connects to their 8442 some
Server.
socket port. Yeah.
So is it connected through
It's
like
connected
the building
to
network?
Yeah. And so we can now dump the. So it just got bound with the.
Yeah. It's explain this.
Yeah, so for a quadcopter, usually they set up between the remote and the quadcopter, for safety reasons, when you turn on the quadcopter, after you turn on the remote, they have a binding sequence. So only when they sync, we can start sending control commands. So just to demonstrate that again, I can turn this off. And if I dump the program again,
So as you can see, he was able to dump multiple programs, one to program the ESP as well as one to program the Arduino core.
and so yeah, and so it's just got bound. So if I So I have complete control is connected via the cloud, and
You can feel the like nearly zero latency. That happens.
so yeah, so we have your page control, and actually we have a slide that demonstrates the
So
working.
what is the user interface on the phone?
Yeah, I just want to add, we have a slide that can demonstrate that. So, yeah. Yeah. So, the interface is very, very easy to set up. We just select buttons, we map them to pins. The API has a standard interface, we map the pin there. So, if you could think of a remote, we have a yaw, so that it rotates right and left. We have the joystick control, which pitches forward, backward, and rolls left and right. And we've set a separate throttle control. And all this is just a trim. It's a $13 thing. So every time we start it starts at a different axis. So this just allows us to calibrate it. So it allows us pitch calibration, roll calibration, yaw calibration. We set in a nitro mode wherein you click start and it can run. And we've also tried to set up an autonomous mode kind of thing wherein we were still working on it like last night. So what we can do, since we have complete control of it, we can set throttle, then delay, yaw it for a while, and then just have one button, it does all that for you. And yeah, so setting up this interface was really easy. Thanks
So
to
where did the app come from? You didn't write the app.
We didn't write the app at all. So the Bleak API
Okay.
comes with an Android APK interface as well. So all this is done by the API, and